Hey, welcome back. Today, let's continue working with our reciprocal functions and with tangent. And I have three questions that are a little more work than just quickly trying to evaluate if we know the angle already. What's that, like we did last time? So today, let's take a look. So the directions say, find the values of all six trigonometric functions in the below questions. So here we have cosine of theta equals, we have the ratio of 24 over 25, where my theta, my angle, is in between pi over 2 and 0. All right, so where are we if we're in between pi over 2 and 0? Before we even start the question, it's always good to draw a picture. Negative pi over 2. I can't remember if I said negative or not before, but negative pi over 2 would be down here, right? I would continue along this way to negative pi over 2. If I went all the way down and labeling like that, looks a little weird. So I'm gonna erase that. So either way, I know I'm in my fourth quadrant. So as we go through these, keep in mind that we're in our fourth quadrant. Let's take a look at the rest. Well, cosine of theta, let's write out what our general cosine of theta is. Well, we know cosine of theta is x over r. So, our r is 25. Our r is no longer 1, so that's another reason why we can't just quickly jump to simplifying. So I know x, they told me, was 24, and my radius is 25. And I know I'm in my fourth quadrant because they gave me this information. So let's draw a quick little picture. So my radius and my x look kind of similar. So I'm going to have a 45-ish looking triangle, right? Those are pretty close to the same here. And so let's write out my x value. I'm going to label my triangle as 24. My radius is 25. And my y is going to be negative, and that's going to be useful. So we're going to want to get that. Let's just do our simple Pythagorean theorem, right, to find the third side of a right triangle. So I have 25 squared equals 24 squared plus y squared. And 25 squared is 625. 24 squared would be 576, but let me double check on my handy dandy, calculator. And again, I don't expect you to know that. I just have squared that number a lot. I think I already know the answer, but let's do our workout. Because you might too. You might know it too if you remember your Pythagorean triples there. So if I subtract, I should get 49. Yep. And if I take my square root of both sides, I get 7. Right, so that's one of those triples, 7, 24, 25. Always good to double check. But in this case, right, I'm in negative y territory. So I'm going to write y is negative 7, so I don't forget. We said x, and I'm going to write them all together. X is 24, and we said my radius is 25. So as soon as I know all three pieces, I can put together all of my other trigonometric functions. Actually, from the beginning, couldn't we have put secant together? Yeah, it's just the reciprocal, right? It's r over x, which in this case is going to be 25 over 24, right? Just flip them. And if I continue along, now that I have my y value, I know that sine is y over r, right? No longer 1. We said r is 25, so let's fill this in. My r is 25, and my y is negative 7. Can't simplify any of these. Let's get the next super easy answer, which is just the reciprocal, right? Flip these around. R over y. So I have r is 25, and don't forget your negative 7. Usually we put the negative in top, but that's okay, right? That's still my cosecant of theta is 25 over negative 7. And our last two, tangent of theta is y over x. So my y value is negative 7, and my x value is 24. And lastly, cotangent, right? Tangent's reciprocal, which is x over y. And so I'm just flipping these, right? Negative 24 over 7. I just put my negative in the numerator. All right, let's try another one. We'll do 3 altogether. Cotangent of theta is negative 12 over 5. So maybe first I'll remind myself, I know what cotangent is. That's x over y, because it's tangent's reciprocal. So I know that x is going to be negative 12. Actually, I'm not sure where the negative is yet, right? Because we're simplifying, we always put in the numerator. So maybe let's just write 12 for now, and 5 for now for my y. And I know tangent already, though. I know tangent. I can just take my original and take the reciprocal. So negative 5 over 12, but I'm not sure technically where that negative is. And this is what's going to tell us. So let's see. Draw a picture. So I'm saying my angle, theta, is in between 0 and pi, right? So I'm in my top two. I don't care about down here. So, let's see. To get a negative out, can I be in my first quadrant? No, x and y are both positive there, so I know I'm over here. And is it x or y that's positive? Well, in my second quadrant, it's the x that's going, well, I said which is positive, so the y is positive. What I'm really looking for is the negative. X is the negative. So if I was to draw a picture and x is 12, that's going to be my longer side. So maybe it looks, I'm just drawing something. I'm going to have negative 12, and really is a side length negative? No, but I'm going to put the negative because I know that my x is negative and my y is positive. All right, let's get our hypotenuse, and you probably already know how to get that, right? I'm going to take my x squared plus my y squared is going to give me my hypotenuse squared, also known as my radius in this case. And you might know this triple, but if not, we can do the workout, right? 144 plus 25 equals, I forgot to write, let's write something there. Let's call it r squared. Well, if I add these, I get 169 equals r squared. And if I take the square root of both sides, I get 13, right? That's that Pythagorean triple of 5, 12, 13. And let's fill that in. So r is 13, so I can relabel that as 13 over here. And the rest is just filling in and knowing my ratios, right? My sine of theta is going to be my y value, right? Maybe write it out in the beginning, y over r. So y, we said, was 5. And my radius, we discovered, was 13. By the way, is the radius ever going to be negative when I'm using my Pythagorean theorem to get that out? No, right? All right, so I have 5 over 13 for sine. I might as well do cosecant. Sine's reciprocal, right? Just r over y, which is 13 over 5. And last but not least, cosine. And again, be careful. I'm in negative land in my second quadrant for my x values. So I have my x value is negative 12 over my, and actually, let's do it the same way. Let's keep it consistent. Let's write out the ratio, especially in the beginning, x over r, right? So negative 12 over r, which is 13 that we discovered. And again, secant, just my reciprocal. Flip these fellows, and I have 13. And I'm going to keep my negative in the top, just because that's by the way we always do things. Most simplified is just bring your negative up. So I bring my negative up here, and I have negative 13 over 12. Is it incorrect if you had left it as, 13 over negative 12? No, and I don't think many teachers would take off. But again, just the way we do things, we always seem to have the negative float up. Just maybe so we don't lose it in the denominator. All right, let's do one last example of these. And maybe I'll bring this down a little so we can see a little less sloppy. All right, cosecant of negative 5. Cosecant of theta equals negative 5, where theta is in between pi over 2 and 3 pi over 2. Okay, pi over 2, I know that's up here, and 3 pi over 2 is here, so I'm somewhere over here, so I don't care about these. And cosecant of theta, normally earlier we said, we thought cosecant was the reciprocal of sine, and maybe even better, let's write out sine first. Sine is going to be y, right, over r, so that means cosecant is r over y, but in this case it's telling me I just have one number. Well, is it really one number? No, I can always make it a ratio if I want to, right? What wouldn't change this? Well, I can always say it's over 1. Right, so now my cosecant is going to be the r is 5 and the y is 1. There's a negative somewhere, and the hint really, I mentioned it before, r is never negative, so I'm not going to have a negative 5. It's going to be a negative 1. But maybe you didn't remember that. So if we pay attention to over here, well, let's plug these in. Say we didn't know the negative belonged with the 1. Well, we know r is 5 and y is 1. Well, where could I get a negative out? Well, if I want a y that's negative, I'm not going to be up here, right? Y is positive up here, and r is positive, like we said, so I have to be in my third quadrant. So let's see. My y is really shallow, so I'm only coming down a little, and my r is 5. So let's fill those in. I got 5 for r. I got -1. Oops, sorry. I got -1 for my y. And let's find out what the x value is. Also, is x going to be positive or negative? Well, it's going to be positive. Sorry, it's going to be negative because I'm in my second and third quadrants over here, right? Technically, we're talking about it being in my third quadrant, but either way, x is going to be negative. All right, so let's find out what that is. Well, let's write out our ratio. Our r is 5, so I have 5 squared, my hypotenuse, my radius, equals -1 squared plus x squared. All right, let's do our math out here. We get 25 equals, well, 1 squared is just 1, plus x squared. Let's subtract. And I get 24 equals x squared. And I take my square root of both sides. This one isn't as pretty as the others, but I think it's pretty. Let's just simplify a little, right? Every number is pretty, I would say. Square root of 24. Well, what goes into 24, or what are factors? I could say, what's a perfect square that's in there? Maybe you just think of 4 first, right? This is 4 times 6, right? If I want to rewrite this, so the square root of 4 is 2. And can I take out anything of 6? 2 times 3? No. So I get 2 square root 6 for when I simplify. All right, there's x. So my x is 2 square root 6. And again, where are we? Third quadrant, negative. Don't forget, y is, we said, -1 already. And my r, we said, was 5. Okay, let's fill in the rest of our ratios. We already knew that sine was just flip these, right? Was y over r. So I have -1/5. Cosine that we just enable us to find is x over r. So my x is -2 root 6 over r is, what did we just say? R is 5, sorry, losing it. And so secant, its reciprocal, is going to be the opposite. Sorry, not the opposite. The reciprocal is going to be r over x. So my r value we said was 5, that we already knew, and our x value is -2 root 6. This is ugly. Are we going to leave it like this? No, we're going to rationalize. So I multiply by root 6 top and bottom. So I get 5 root 6 over 6 times 6. Root 6 times root 6 is just 6. 2 times that is 12. And bring along your negative. And so I'm looking at, let's make this a little neater, whatever this lovely number is. 5 times root 6 over 12, -12. Tangent is y over x. So I take my y, which we said already was -1, and I put it over my -2 root 6. And again, that's not pretty. Let's rationalize. So I get -root 6 in my numerator, and I get that same root 6 times root 6 is 6. I get that same -12. And the nice thing here, tangent, and it's a kind of a nice self-check. Well, if I'm doing all my math correctly and everything I've done so far, I'm canceling my negatives here, tangents should be positive, right, in your third quadrant, because both x and y are negative. A negative divided by negative is a positive. So it's a nice little self-check. And finally, cotangent, who should also be positive, right, in that third quadrant, which is x over y. My x, we said, was this -2 root 6, and my y is -1. If I simplify, I get a +2 root 6. All right, I hope these helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples, or if you want another topic to be covered.